Today is the final episode in our Big Bang Theory series of videos. Today we're going to be talking about the ultimate fate of the universe, going into a couple different ways that scientists today think that the universe might actually end. And then we're going to finish off this whole series of episodes with some extras, like problems and related issues in physics. I feel like that's a good topic to kind of explain maybe some ways that the theory doesn't work, and just kind of go on the other side of the spectrum. Some misconceptions about what people think about the Big Bang that was, really not true. And then some religious and philosophical interpretations. So yeah, I hope you guys like this episode. Alright, welcome back to Down the Line. I'm your host, Pete. And today we're going to be talking about the ultimate fate of the universe. And now there are a lot of competing scenarios for the possible long-term evolution of the universe. Which of them is going to happen depends on the precise values of physical constants, such as the cosmological constant, the possibility of proton decay, and the natural laws behind the Standard Model. So there are a couple different ones that we're going to get into today, but the first one is going to be the most accepted right now, what we think is probably the most likely to happen. And technically there are two parts. There's the big freeze and the heat death scenarios, and they kind of work the same way. Basically, the universe will just get to an absolute zero temperature, and that'll happen either with the big freeze or the heat death. It's a scenario under which continued expansion results in a universe that asymptotically, fucking word again from last episode, approaches absolute zero temperature. This scenario, in combination with the Big Crunch scenario, is currently gaining ground as the most important hypothesis. It could occur only under a flat or hyperbolic geometry. So we are going to get into the Big Crunch scenarios too. That one I think is a little less scientifically accepted. It used to be the most scientifically accepted, and now it's kind of changed into this one. Eventually, the supply of gas needed for star formation will be exhausted. As existing stars run out of fuel and cease to shine, the universe will inexorably grow darker. Eventually, black holes will dominate the universe, which will themselves disappear over time as they emit Hawking radiation. And so what it looks like here is that the temperature of the universe will become a still thing. It won't move any lower or higher. It'll just stay exactly the same. That's actually a big problem for the universe, because most of the changes that happen are temperate changes. Like the conversion of helium or hydrogen into helium in stars is done by heat. And so if the temperature stays the same, elements can't change into, protons can't combine, all these things, they can't happen anymore. And so all the stars that we have now will eventually burn out, become black holes, and those black holes will eventually fade. And so all that will be left in the universe is just this stretching emptiness that will expand forever. A related scenario is heat death, which states that the universe goes into a state of maximum entropy in which everything is evenly distributed and there are no gradients which are needed to sustain information processing, which is one form of life. The heat death scenario requires that the universe will reach an eventual temperate maximum. So it kind of is the same kind of scenario, as the temperature will reach one still thing. And you could either say it's heat or a big freeze. So that's the most currently accepted model. The one that used to be accepted and is kind of losing ground now is Big Crunch. This theory assumes that the average density of the universe is enough to stop its expansion and begin contracting. The end result is unknown. A simple estimation would have all the matter and space-time in the universe collapse into a dimensionless singularity. But of these scales, unknown quantum effects still need to be considered. Recent evidence suggests that this scenario is not likely, but has not been ruled out, as measurements are only available over a short period of time and they could reverse in the future. So for this one, it looks like the universe will eventually stop expanding and kind of revert back to its original point, which would mean that the universe would get back into this little tiny thing that it was when the Big Bang started, and that would just collapse upon itself, kind of just crash into each other. The next scenario that we're going to look at is called the Big Rip, in a special case of phantom dark energy, which has even more negative pressure than a simple cosmological constant. The density of dark energy increases with time, causing the rate of acceleration to increase, leading to a steady increase in the Hubble constant. God, I said increase like 20 times in that sentence. As a result, all material objects in the universe, starting with galaxies and eventually in a finite time, all forms of matter, no matter how small, will disintegrate into unbound elementary particles and radiation, ripped apart by the phantom energy and shooting apart from one another. So for this one, the way I kind of think about it is like, say me and you are playing like tug of war, and the rope that we're pulling is the universe. So me and you are phantom energy, and we're pulling the universe, and eventually it's just going to rip and just like split upon itself, and that's going to be the universe, and they're going to shoot apart from another. So yeah, that one sounds particularly terrifying. Luckily, they don't think that this one is going to happen. Same with the next one. These ones are kind of just more like interesting to think about. But there's some ideas why we think it might happen, but it's most likely not going to. The next one we're getting into is the false vacuum. A true vacuum exists so long as the universe exists in its lowest energy state, in which case the false vacuum theory is relevant. However, if the vacuum is not in its lowest energy state, a false vacuum, it could tunnel into a lower energy state. This has the potential to fundamentally alter our universe. In more audacious scenarios, even the various physical constants could have differing values, severely affecting the foundations of matter, energy, and space-time. It is also possible that all structures will be destroyed instantaneously, without any forewarning. Studies of a particle similar to the Higgs boson support the theory of a false vacuum collapse billions of years from now. So this one's kind of more like you could have this like lower energy, which would be the false vacuum. It would tunnel into lower energy states, and that would alter everything. It would change space, time, and matter, how everything works. And that would probably, kill us, but it's very interesting to think about. This next one is actually my favorite one, and I'm saving it for last because I think it's the least likely to happen, but I think, maybe. I like it, though. It's one of my favorites. It's called the Big Bounce, a theorized scientific model related to the beginning of the known universe. It derives from the cyclic repetition, I think it's how you pronounce it, cyclic, interpretation of the Big Bang, where the first cosmological event was the result of the collapse of a previous universe. I love that. It's so interesting to me. The beginning of a universe was came from the end of a previous one. So this is also not just like an end of the universe theory. This is also the beginning of a universe theory. It's like an alternate Big Bang theory. So according to one version of the Big Bang theory of cosmology, in the beginning the universe was infinitely dense. And such a description seems to be at odds with everything else in physics, especially quantum mechanics and its uncertainty principle. It is not surprising, therefore, that quantum mechanics has given rise to an alternate version of the Big Bang theory. In simpler terms, this theory states that the universe will continuously repeat the cycle of a Big Bang followed up with a big crunch. So I really like this. So it's saying that the Big Bang theory itself has a lot of issues with quantum mechanics. There are a lot of things that don't add up right now. We haven't figured it out yet. So this is kind of like we have a solution for it. It's saying that there's the Big Bang, right? And it happens, and the universe stretches, and it goes on until the end of the universe, where it will contract like the Big Crunch. It'll combine back into its infinite size and collapse upon itself. And then at that little second, where it's at pretty much 0 seconds, when it's at the smallest size it can be, it redoes itself. And it's just an infinite cycle of universes. I really love that for some reason. That's kind of what I think I talked about this in my last episode. That was kind of already something I truly believed, that the universe was just in a repeated cycle that would just go on infinitely, and that we're not the first universe and we're not the last. And it does say that this probably isn't super likely, but I like that it's actually considered with one of the theories. I think it's awesome. And the last one technically is not a end of the universe or fate of the universe. It's just important, I think, to add about cosmic uncertainty. Each possibility described so far is based on a very simple form of the dark energy equation of state, but as the name is meant to imply, very little is known about the physics of the dark energy. If the theory of inflation is true, the universe went through an episode dominated by a different form of dark energy in the first moments of the Big Bang, but inflation ended, so an equation of space far more complex than those assumed so far for present-day dark energy. It is possible that the dark energy equation of state could change again, resulting in an event that would have consequences which are extremely difficult to predict. As the nature of dark energy and dark matter remain enigmatic, Jesus Christ, I can't talk, even hypothetical, the possibilities surrounding their coming role in the universe, they're currently unknown. So I think that all it's really saying is we don't know. We don't know enough about dark energy and how it works to really have an exactly accurate idea of how it's going to end. I mean, we don't even really know for sure how the Big Bang happened. We're still figuring that out, and we're still going to be figuring it out how the universe is supposed to end, probably even later than that. And that's I guess where we end all that. That's a bunch of ways that the universe might end. And hopefully, with the end of it, a new one will begin. I mean, I think of the universe like a life. I mean, it starts and then it ends and then another one starts after. But now we're going to go into some extras. And I think I should start with the problems and related issues in physics. I'm not going to go into exactly the issues that they are, because some of them are really mathematical and complicated, but I think it's important just to note that there are some problems with it. I mean, as with any theory, a number of mysteries and problems have arisen as a result of the development of the Big Bang Theory. Some have been resolved by other theories like the inflation theory. So before there was inflation, there were a lot of plot holes in this, and inflation kind of helped that. But others have still yet to be solved. And while the Big Bang model is well established, it is likely to be refined. So it's probably not going to stay this way forever. It's definitely not. They're gonna figure out better ways to fix this. And the inflation theory itself is actually it's given more questions, like quantum mechanics. It kind of goes against physics. So that's something that we need to figure out. Another thing I was going to get into is the misconceptions. I've heard this personally in my life too, about people saying the Big Bang Theory is the universe or the origin of the universe, and it's not. It actually doesn't comment on how the universe came into being. I mean, you would notice that from just hearing all my episodes. The theory assumes the existence of space, time, and energy, but makes no comment on their origins. It never says how any of that began. Oh, also, the Big Bang was not small. It is misleading to visualize the Big Bang by comparing its size to everyday objects. When the size of the universe at Big Bang is described, it refers to the size of the observable universe, not the entire universe. So I think that's definitely an important thing to note too, is when I say everything was very, very small, what I'm talking about is the observable universe, what we can see now. So that's not the entire universe. I don't think we would ever be able to know, because we've never been able to see any farther than that. And lastly, I'm going to get into some religious and philosophical interpretations. And I feel like that's important too, because that definitely kind of goes against a lot of those ideas. As a description of the origin of the universe, the Big Bang has significant bearing on religion and philosophy. As a result, it has become one of the liveliest areas in the discourse between science and religion. Some believe the Big Bang implies a creator, and some see it's mentioned in their holy books, while others argue that the Big Bang cosmology makes the notion of a creator kind of pointless. And for me, I don't really have an opinion on it. I'm open to a lot of different beliefs. Me personally, I don't believe in a lot of the main religions that we have now. But I don't think if there was a creator, I don't think we will ever really know. I don't think that I just don't think it's something that we can know. And there's no thing we can really prove right now. So until we get some proof, I don't think I really have any say in it. I mean, the universe happened the way it happened, and it almost doesn't matter right now if it was because of some holy being. I mean, if it wanted to be known, I think it would make itself known. And for the other religions, I guess the main problem I have with them is that they were made by man. We have no proof of anyone else having made them, or even come up with them. I don't know. There's a lot of issues, including in this theory too, the Big Bang Theory. There's a lot of issues in any origin theory, and I just don't know. I guess until we get more proof, which is the Big Bang Theory is the most proof that we've ever had. We can actually observe it. And we can't really do that with these other religions, and that's kind of my issue with it. But I'm not against other people believing it, and I'm all for the conversation. I do like that. So I would love to see, if you guys see this video and you want to comment on it, I'd love to see some comments and have some debates. I don't know. I'm very curious too about the way that works. Because I grew up religious, and I actually grew up I didn't come from a super religious household, but I did go to church a little bit. And I think more of my own curiosity about religion came from myself, not from my family. And then, I made my own decision when I was older. I think for me, the biggest thing is, I would guess I'm a realist. I mean, it's very hard for me to believe in something that I can't see. And I guess some people don't like that, the idea that, like they say, seeing is believing. But I mean, that kind of is true. And I think it's, for me personally, I wouldn't want to blindly accept something because someone told me to. That's just my, I guess, belief system. So, but yeah, I guess that ends the whole Big Bang Theory right now. That ends this little series of Big Bang Theory episodes. The next one we're actually going to get into is the very, very beginning of Earth. And we're just going to go from there. We're going to go from Earth. We're going to go to when people, not just people, but life in general, came here. We'll get into people. We'll get into other beliefs too. And we're not just going to talk about it. The Big Bang Theory is not the main idea of this channel. This channel is supposed to be all of history. So I went from the Big Bang because it's what we believe to be accurate history right now, as accurate as we can get. And I'm going to get into even some of the stuff that I don't believe. I'm going to get into all the religions. I do want to. I feel like it's very interesting, and I've always been fascinated with it. So yeah, I guess that's a good place to end this episode. I really hope you guys enjoy. I hope you guys enjoy this whole series. I mean, I had a lot of fun looking up this stuff. I learned a lot, and a lot of these misconceptions for the Big Bang were my own misconceptions that I didn't know about. So I'm very, very glad that I learned all this stuff, and I hope you guys learned some stuff too. So I'll see you guys next episode on a completely new series. It's not going to be a new series. It's still going to be, down the line, still linear. But we're not going to be talking about the Big Bang anymore. We're going to talk about Earth. And it's going to be really fun. So I hope you guys enjoyed. I'll see you guys next time.